All right, so we did some enrichment problems today, and I will post them at the end of the recording so that those of you who are doing this online can have access to the questions themselves. So problem number 1 tells us that a compound is 9.93% carbon, 58.6% chlorine, 31.4% fluorine, and we want to know what's the empirical formula. Okay, so the first thing we have to do is we pretend we've got a 100-gram sample, right? Because if we pretend we've got 100 grams, then that makes turning all these percents into grams really easy. So we say, okay, that's 9.93 grams carbon, and we're going to convert everybody to what? Molecules? Moles, right. So we have to use the molar mass, yes. So the molar mass of carbon is 12.011. So 9.93 divided by 12.011 gives me 0.8267 moles. Now we take chlorine, which is 58.6 grams, 35.45 grams per mole. So that gives me 58.6 divided by 35.45. 1.653 moles, and 31.4%, it's now grams. Fluorine's what? 19 point something something. 18.99. 18.99 grams per mole. All right, so 31.4 divided by 18.99 gives me 1.6535 moles. So now I've got everybody in moles. What do I do next? What do I do next? Divide all of them by the smallest value, right? So I pick the smallest value, which is the 0.8, 0.8267. 0.8267, 0.8267. So this equals 1 divided by 0.8267. This is 2. This is 2. So therefore, my formula, my empirical formula, is CCl2F2. Do we agree? Now, if you wrote those in a different order, that doesn't matter. Okay, as long as your ratios are the same, right? 1 carbon, 2 chlorines, 2 fluorines. Does the ratio 1 to 2 to 2 reduce any further? No. So I know that I came up with an empirical formula. Any questions on number 1? Everybody good on how to do number 1? All right, let's go on to number 2. So number 2 is a little bit different in how it was worded, right? Because the problem says characteristic odor of pineapple, blah, blah, blah. If a sample contains 0.62069 grams carbon, 0.103448 grams hydrogen, 0.275862 grams oxygen. I want to know what's the empirical formula. I didn't give you percents, did I? I didn't, right? So you look at the problem and you say, okay, that means that a sample, some quantity, probably a gram, right, was made of 0.6 grams carbon, 0.1 grams hydrogen, 0.2 grams oxygen. Therefore, it's already in grams for me, right? I don't need to convert percents to grams because it's already in grams. Does this make sense? So I can just go ahead and convert grams to moles here. Probably should have given myself a little bit more room. So let's convert grams to moles. And let me rewrite those values. It was 0.103448 grams hydrogen and 0.275862 grams oxygen. So if I give you grams, that saves you a step, right? You don't have to convert those percents into grams if it's already given to you in grams, right? I'm telling you a 1 gram sample was composed of this, right? So it's already in grams. I can just do my conversions. Don't need to convert percents to grams because it's already in grams. All right, so 0.62069 divided by 12.011, 0.0516, let's go 8, and then 0.10348 divided by 1.008, 0.1026, 3, and then 0.275862 divided by 16, 0.01724. And these are all moles. So now I pick the smallest one, which is this one, right? So I divide it by 0.01724, by 0.01724, 0.01724. Am I still in the frame? Yes. Okay, so that's 1.10263 divided by 0.01724 gives me 5.95, which will round to 6, and 0.05168 divided by 0.01724 gives me 2.997, which will round to 3. So therefore, my empirical formula is C3H6O. Now, if that O was not there, that would not be an empirical formula, would it? Because 3 to 6 does reduce. But does the ratio 3 to 6 to 1 reduce? No. Okay. So that is an empirical formula. Does everybody understand how we did number 2? Slightly different because I didn't give you percentages, right? I didn't say it was 90% blah, 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 and 10% blah, blah, right? I just gave you the masses straight up. So anytime you're given masses to begin with, you just take those numbers and run, right? You don't need to convert percents to masses because it's already given to you as masses. Does number 2 make sense? Everybody good on number 2? All right, let's go through number 3. So number 3 asks us, oh, that was the empirical formula was C3H6O. Number 3 says if the molecular formula has a molar mass of 465, how do I get the molecular formula? So what do? To convert an empirical to a molecular formula, I just multiply everybody by a number, right? And I have to get that number. I don't just make up a number. So how do I get that number? The number we multiply by is the molar mass of what? Well, of the molecular, right, which is given, over the molar mass of the empirical, which you have to calculate, right? This is given, so that's 465. I've got to calculate the molar mass of the empirical. That's on my job. Okay, so 3 times 12.011 plus 6 times 1.008 plus 16. I got 58.081. Did you? Depending on how you rounded. So 465 divided by 58.081 gives me 8.006, which will round to 8. Did you get 8 as your factor? So now what do? I multiply all of these by 8. 8's a pretty big factor to be multiplying by, but if that's the value you get, that's the value you get. All right, so my molecular formula is C, what's 8 times 3? And what's 6 times 8? And 1 times 8. There's my molecular formula. Now, does that make sense given the fact that its molar mass is 465? Yeah, right? Because that's a big molar mass, so you would expect a big molecule, right? You wouldn't expect, you know, H2O, right? That's a big molar mass, so therefore it makes sense that I've got a big molecule here. Questions on number 3? Everybody good on number 3? Okay. Let's do number 4. So in number 4, I tell you that a compound is 67.6% Hg. What's that? What element is that? Mercury. 10.8% sulfur, 21.6% oxygen, and I want to know its empirical formula. So we're going to use the same procedure we did in number 1, right? We're going to convert all these percents to grams. Then we're going to divide, we're going to convert all these percents to grams. Then we're going to divide them all by molar mass. Then we're going to divide by the smallest one. So mercury's molar mass is 200.59, 67.6 grams, 200.59, 9 grams per mole. And 10.8 grams sulfur. Sulfur's 32.066 grams per mole. And 21.6 grams oxygen, 16 grams per mole. So 67.6 divided by 200.59. Gives me 0.337 moles. 10.8 divided by 32.066 gives me 0.3367. So in other words, it's basically the same moles. 21.6 divided by 16, 1.35. Oops. Don't forget my units. Now we're going to divide through by the smallest, right? So we're just going to call that 0.337 as well. So divided by 0.337, that gives me 4.0059, so 4. So my empirical formula would be HgSO4. Do we agree on this one? Makes sense? Did you get it right? You made a mistake, you see we made it? Okay. Let's see, number 5. This one is not an empirical formula problem at all. It's a percent composition problem. So number 5 asks us, what percent of magnesium carbonate is oxygen? Okay, well, this is a good test of formula writing, right? Because if you can't write the formula, you can't do the percent composition. What's the formula for magnesium carbonate? MgCO3, right? Because magnesium ions +2, carbonate CO3 -2. So how do I get percent oxygen? It would be mass of oxygen over total molar mass, right? So 3 times 16 divided by the total molar mass. So let's see. Magnesium is 24.305. 30. So I came up with a total molar mass of 84.316. So when you multiply that out, divided by 84.316, That gives me 0.569, which is the same thing as 56.9%. Do we agree? Do we agree? Yes, yes, yes. All right, let's do the next one. Number 6 tells me a molecule has the composition 50.7% carbon, 9.9% hydrogen, 39.4% nitrogen. And I want to know what's the empirical formula. Okay, so here we go. 50.7 grams carbon, 12.011 grams per mole. Are any of you memorizing your molar masses yet from doing the same ones over and over? Yep. Feels scientific, doesn't it? All right, 9.9. Try dropping that casually into conversation the next time you're hanging out with your friends. 1.008 grams per mole. 39.4 grams nitrogen. 14 grams per mole. All right, so 50.7 divided by 12.011. That's 4.2211 moles. 9.9 divided by 1.008. 9.821 moles. And 39.4 divided by 14. 2.814 moles. All right, dividing all by the lowest. So 9.821 divided by 2.814 gives me 3.49, 3.5. Uh-oh, I've got a number ending in 0.5. 4.2211 divided by 2.814. That gives me 1.5. Even if I only had one value ending in 0.5, it doesn't matter that I've got two values that end in 0.5. Even if I only had one, what would I do if I get a value that ends in 0.5 ever? Double not just that value, but all the values, right? Because that's the same as 3.5. Just like when we're trying to get rid of a fraction, when we're having our coefficients and one of them's a fraction, right? You multiply all of them. You're going to do the same thing here. We want to get rid of that half, so you go out and multiply everybody by 2. So that gives me 3, that gives me 7, that gives me 2. So my formula is C3H7N2. Do you see why we had to multiply everybody by 2? There's another scenario where you got to multiply everybody by a number. What is that? If you get a 0.3, right, that's like a third. So if this had been 1.33333, right, that's a third. We multiply everybody by 3. And it doesn't have to be more than 1. If you just get 1, that's enough to do it. Okay. Does everybody understand what we did here? So the empirical formula is C3H7N2. And then the next problem goes along with this one. And it says, as soon as I get the board erased, the next problem says, if the molecule in number 6 has the molecular formula, so the molar mass of molecular, 142 grams per mole, what is the molecular formula? All right, so we have to figure out what number we're multiplying everybody by, right? So it's molar mass of molecular over the molar mass of empirical. So 142 divided by, we've got to figure out what the molar mass of the empirical is, right? So 3 times 12.011 plus 7 times 1.008 plus 28. That gives me 71.8 0.089, so that's going to be about 2. 142 divided by 71.089. It gives me 1.997, right, so we're multiplying by 2. So therefore, the molecular formula, multiply everybody by 2, right? So that would be C what? 6H14N4, right? Do we agree on number 7? Number 7. Everybody good on number 7? You made a mistake, you see where you made it. Okay, last one. Number 8, what is the empirical formula of a compound made of 6.71% hydrogen, 40.0% carbon, and 53.3% oxygen? All right, so we're going to go through this same procedure again. We really want to make sure we know how to do this, right? 6.71 grams hydrogen times 1.008 grams per mole. 40.0 grams carbon times 12.011 grams per mole. And 53.3 grams oxygen times 16 grams per mole. All right, 6.71 divided by 1.008 gives me 6.7, which will round up. Make sure I type that in, right? 6.71 divided by 1.008. Yep, 6.7. Okay, so we'll round that up because there's no rule for 0.7, right? So we just round it up. 40 divided by 12.011. That gives me 3.33. Uh-oh, I got a problem. And 53.3 divided by 16 also gives me 3.33. Okay, what do I do with a third? We what? Triple everything, right? So times 3 times 3 times 3. Okay, so 7 times 3 is 21. 3 times 3 is 9. 3 times 3 is 9. Right? Well, 3 and a third. 3.333333 times 3 gives you 9.99999. So actually, that's not 9, that's 10. Because I'm looking at that going, 21 to 9 to 9. Well, that don't make sense. That would reduce. 21 to 10 to 10, that does not reduce. Because that's the third. Forgot to factor in that third there, right? So 21 to 10 to 10 does not reduce. So my empirical formula, and again, the order isn't going to matter, right? Typically, you write the carbon, then the hydrogen, then the oxygen. C10, H21, O10. But again, the order would not matter. The order would not matter. Okay. Yes?
So whenever it ends in one of those numbers, we don't have to worry about dividing it by the...
Oh, you're right. I didn't divide through by the smallest. Boy, thanks for pointing that out. That would be a big time mistake. And so if you did something like this on a test, I would just -1 for that, right? Because that's a simple mistake. So yeah, you're right. I didn't go through and divide by the smallest. Thank you for pointing that out. Divided by 3.33. I guess I'm just so excited about being done. I jumped ahead. Last problem, woohoo! Okay, thank you. So 7 divided by 3.333 gives me 2.1, which we round to 2. That's 1, that's 1. Yes, that's CH2O. That's a big difference in answer, right? So if you forget to divide that step like I did, I just got excited. We're almost done. I want to go eat lunch, right? You forgot to do this on a test, but you carried it through correctly, I'd probably only take 1 point off for that. So thank you for saying that, because yeah, otherwise I would have something grotesquely wrong. Good catch. All right. Have a good day. I'll see you on Friday.